This lesson shows how to solve absolute value greater than inequalities. The lesson begins with a question. What's the meaning of this statement? What are the set of numbers on the number line whose absolute value is greater than 3? To begin with, it's easy to see that all the numbers greater than 3 have absolute value greater than 3. For example, look at the number 4.5. The absolute value of 4.5 is positive 4.5, which is greater than 3. Next, notice the negative numbers less than negative 3 have absolute values greater than 3. For example, look at the number negative 3.5. The absolute value of negative 3.5 is positive 3.5, which is greater than 3. So the set of numbers with absolute value greater than 3 is the set of numbers less than negative 3 or greater than positive 3. Notice you've seen this picture before. This is the graph of a disjunction, a compound inequality joined by the word or. So this absolute value inequality is equivalent to a disjunction. And therefore, it should seem reasonable to solve an absolute value greater than inequality. You write and solve an equivalent disjunction. Here's an example. Absolute value 2x plus 1 greater than 3 is equivalent to the disjunction 2x plus 1 less than negative 3 or 2x plus 1 greater than positive 3. On the left, subtract 1 from both sides for 2x less than negative 4. Then divide both sides by 2 for the first part of the solution, x less than negative 2. On the right, subtract 1 from both sides for 2x greater than 2. Then divide both sides by 2 for the second part of the solution, x greater than 1. And the solution to the inequality is all the numbers less than negative 2 or greater than 1. Then there are two boundary checks at x equal negative 2 and x equal 1. For the boundary checks, rewrite the inequality as an equation and substitute the boundary values. On the left, 2 times negative 2 plus 1 is negative 4 plus 1, and negative 4 plus 1 is negative 3. And since the absolute value of negative 3 is 3, the left boundary checks. On the right, 2 times 1 plus 1 is 2 plus 1, and 2 plus 1 is 3. And since the absolute value of 3 is 3, the right boundary checks. Going back to the solution, we'll select two values for inequality checks. Any convenient value less than negative 2, like x equals negative 4, and a value greater than 1, like x equals 2. To do the checks, rewrite the inequality and substitute the selected values. On the left, 2 times negative 4 plus 1 is negative 8 plus 1, and negative 8 plus 1 is negative 7. Since the absolute value of negative 7 is 7, You have the true statement 7 is greater than 3, and the left inequality checks. On the right, 2 times 2 plus 1 is 4 plus 1, and 4 plus 1 is 5. Since the absolute value of 5 is 5, you have the true statement 5 is greater than 3, and the right inequality checks. So to solve an absolute value greater than inequality, write and solve an equivalent disjunction. This lesson showed how to solve absolute value greater than inequalities. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.